Not one person took a thought to how to actually put a data frame together, or if that data frame would satisfy our needs for this week. Nobody did any of the prep that we asked you to do in getting a working data table for this lab today.
I pulled in 4 stations, but I didn't really have any success isolating things or sorting them. But
okay, great.
I had a bunch of other stuff to do, so I probably would have if I'd had a bit more time.
Okay, no, it's great to hear. So what did you run into? These are all great things. You know, not succeeding is just as good in this case as succeeding, because that's how you learn these things. So what kind of went sideways? What didn't work? Or where were you thinking of going that didn't lead anywhere?
And everyone can share at any point as well.
Yeah, if you so chose, Nigel.
I only tried a couple of things, mostly just using different. I was trying to use calls to, I don't know. I got kind of confused with how all of the reading in of things works, and I had like some success, but I kind of just deleted it all at the end because it didn't give me the result I wanted.
Yeah, been there, done that. Gotten to a point when going, you know what, it's better that I throw this away and try a different approach from scratch. So, well, great effort. I mean, can you tell us any more than use calls as including a way inside your read CSV inside the glob that you could try to parse out columns? Was there another thing you tried?
Not yet.
Okay. Anybody else do anything more than what I shared last week?
Stormy's saying she pulled in some stations.
Yeah, I've got 4 stations in there, but I that's all I've done though. But I was, yeah, I don't know.
So did you get those 4 stations pulled in and 4 data frames?
Yes.
Okay. Did you look at those data frames at all and think about what you may have to do with it to answer the questions?
No, like, I guess I can like see, I did like the DF and pulled like the whole thing into there, so I can see, but I haven't analyzed it yet.
Okay.
I'll look at it right now.
Okay, well, that was a quick 4 minutes that I was hoping would be longer discussion. So I'm not going to let everybody off the hook that easily. I'm going to start sharing my screen and putting things up, and I am going to strongly encourage others to chime in. And this is your last opportunity. I will reiterate. This is a great way. I'm giving you a tool, but you've got to know how to use the tool. So if you're not thinking about how we're bringing the data in, what the data looks like, and what manipulation you may have to do, whether you know the code or not, to get to your result, then this is almost all for nothing. Okay? So I'm hoping some of you really dig into that and just at least do the mental kind of thought process. And even though you don't know all the coding, I've given you some of the tools, and together maybe we can work through those tools as I will show you in the lab today. I wanted to pull up, David posted on Brightspaces in week 11, the Lab 5 station list, for those of you who haven't seen it. And he posted the Lab 5 question sheet. So a little different than we've done in the past, because we haven't had the lab questions up prior to our second week lab, but today I want to go over that with you a little bit to give you added guidance. So please, if you haven't done so already, please go on to Brightspaces, download it. You will need it for the lab, and I will be speaking through it today. Anybody else, last chance, that tried anything or even thought about what may need to happen to this data frame for us to get some results? Okay, good. Thanks, Kimberly. Yeah, parse dates, right? That's something we've been doing. Something that we should try to do, right? I mean, we know there's dates. We want to try to do that. Good. Tried that too. Good. Okay, well, that's great. You know, it doesn't always have to work, but yeah, we learned to parse dates. That's something we kind of work with. So, you know, if we're going to use month or day or year to categorize by, if we haven't parsed them, we can't do that. So we should start looking at how to parse them. So good. Excellent. Okay. That's what I'm looking for. Anybody else? While we're all pulling down that Lab 5 PDF. And I will start my screen share. Date time index. Right. If we can parse dates, let's put it into the index. Also, great. Today, I'm going to share just a window instead of my screen. So let me know if it's super squished or really unusable. Because I'd really like to be able to split my screen up. Okay, so if everybody's taken a look at that Lab 5 questions by now, you'll notice that there's some reading. It talks about the model, the PKIC data sets, and that. I'm not going to talk about that at all. David tells me that Johan did a little bit of a spiel today. He talked about it last week. That's on you to dig into, dig your heels into on your own. What you'll need to do is you'll need to find the values that you want from there based off of the stations you've chosen. And then you'll be able to put those values just manually into a little spreadsheet like David has shown on the PDF. Okay, so I'm going to let you tackle all that on your own, unless you have specific questions, and you can come to David and I in office hours on those if there's some confusion. But that's the bulk of the heavy mental lifting in this lab. What I want to direct you to is that we're picking a handful of locations, and what we're looking for are the observed January minimums and January maximums. Okay. Now, this is all being pulled from the minimum monthly near surface air temperature. Okay. So this is really important to take note of. So the minimum monthly near surface air temperature. We want to know the minimum monthly near surface air temperature and the maximum minimum monthly near surface air temperature. So it's a little hard to wrap your head around, but we're looking for the max and the min of the minimum monthly. All right. So this is the only data column variable that we're interested in our station data sets that we're downloading. Okay.
Sorry, Adam, can you say that one more time a little bit slowly, just so I write it?
Okay, we're going to go over it in the code as well, but for the station data, for our observed data, we're going to use the minimum monthly temperatures. And from the minimum monthly temperature data, we are going to find the minimum and the maximum temperature. Okay. So this isn't the January minimum temperature and the January maximum temperature. It's the minimum temperature variable and finding the max and min in that temperature variable. Okay. All right. And that's it for the lab, right? We gotta find those January, July minimums, and then you're gonna be pulling, the 5 GCM or IPCC models and getting their model minimums, maximums, or minimum max, and then you're gonna finding the difference between them. Okay. So one side is going and getting the models numbers, and the other side is pulling the observed numbers. So you're letting you free on finding the model values yourself, And everyone's going to be different because you're picking a different station and therefore a different grid cell on the model. However, I will be helping you with the code to get all of those observed values and work through it, because as we've just kind of reviewed here, the minimum, the maximum, minimum starts to get a little confusing. And how are we going to get from our downloaded dailies to this minimum January value, minimum January value for all of our years? Okay, so that's the conceptually tricky coding bit that we're going to go through today. Okay, so please do bring up that Lab 5 questions and read over it and understand what we're trying to do here. And be sure to take your own notes, carrying on from last week and or copying what you can, knowing I will provide you the notebook in its entirety. All right, so here are our libraries, modules, right? We all know that by now. We should have these in from last week. I think the only one I've added is Plotly. Okay, we're going to be, always nice to take a look at the plot on them, although we are going to be using Plotly a little differently this week, and I'll share you that surprise with you a little later. So first things first, let's start with our stations. So this should look familiar. Maybe I'll try to make this a little bigger if that helps people. Kind of did, kind of didn't. Here, this should look somewhat familiar. It's the syntax has changed a little bit, probably from the one that you had, but this is because I've built it into a bigger script that I'll show you. So it should look familiar though for Y in the year range. We've got our year, and here I'm just taking our year that's a number or an integer and making it a string because we're going to use it in our file names. And I've got another variable here for station ID, and I'm naming that STN, and I'll show you why later. But this variable is just calling another variable, okay? And that's going to be our station ID. And then just as before, we've got our P value that stands for our parameters for our GET request. We won't dig into too much of this. You can use it verbatim, but you'll notice that we've got a bunch of hard-coded text that's required by the website. But we have the two variables, station ID and year. Okay. Maddie's asking a question, do we still need month? Maddie, I sent out an announcement last week of an issue that I found from our lab while working with tomorrow's lab, that months are creating duplicates. So if you had a chance to load this in and take a look at the data, some of you would have noticed that there were duplicates everywhere. One of the things I was probing for today. However, yes, Maddie, don't worry about it too much, because the code I will give you will make sure there's none of those duplicates being created. The reason was that for some reason, the way the government, the climate weather website read the parameters, just wouldn't do anything other than daily. So we're going to end up with daily, but that's fine. We don't mind. We've got code. Okay, so there are parameters. We've got them in. We're using a couple of variables. And then we've got our GET request, right, using our parameters. And then we got our file name. We set up our folder, and inside the folder, we're using our station and our year to list our CSVs. The last line here is what does the heavy lifting. It takes the variable file name, okay, it opens it. WB means it's writing a file, a new file with this name, file name, and then it's .write, it's writing the r.content. So that's the result of our GET request content. Don't worry about this too much other than knowing that that's what it's doing. It's going out to the internet and it's getting your station data. Okay. All right. So that being said, if I ran that right now, it's not going to work. Okay, because I've bulked up my code a little bit. And I've got this variable, I've got two variables here. I've got a year range and station number that I haven't created. Okay. So what I ended up doing was I figured that because we're doing multiple stations, and I thought, you know, I'm going to do my best for these students and see if I can make things a little bit easier. So what I've done is I've taken the one we just reviewed here, the for loop. So this is for all the years in the year range of interest. I've nested that under another for loop. Okay. So we'll talk about the variables inside here. We're going to create a new list called station list. I haven't created it yet. I'll show you in a moment. Inside this station list, we're going to have our station numbers or station IDs. Sorry, we're going to have our station IDs. I may even change that name. But anyway, we're going to have our station IDs and our station years. We're going to pull it from our list that I'll show you how we create it in a minute. We got a variable here that says number of years. Okay, I've set mine to 3, but you'll be setting that to 30. I didn't set it to 30 just because I'm doing a test set here, but when we run it, we're going to want to set that to 30 years because that's the time frame we're looking for to compare to these models. Okay, and then I've got my year range. And you'll see here, it calculates the year range, and that's what we're calling in our second loop. So year range here is going to be taking our number of years, which we set right here, currently is set to 3. So it's going to say 3 years in our number of years. And it's going to take our station year from our list. I'll show you that in a moment. And it's going to add 1 to that for the number of years. So for 3 years, it's going to go, say, 2008 plus 1 is 2009, 2008 plus 2 is 2010, and it's going to create our year range. And here, we're going to look at all of the years inside our year range. Okay, still following? It's starting to get complicated, isn't it? This is why I'm building it for you. Okay, so how did we get station list? And why are we doing these things for our station list? So that looks like this. So what I've done here is I've created a variable named station list. So let's break this out a little bit. So I've got I'll do that. One set of closed brackets, okay, that starts all this. And then I've got one set of closed brackets, second set, third set, fourth set. Okay. And so I've got my second set of closed brackets with 2 items separated by a comma and each of the other closed bracket sets, paired sets, separated by a comma. So here I've got my station ID. I picked 129, 65, 269, and 402 as my stations. Then what I've done here is I've taken my most recent year based on that Excel spreadsheet or CSV spreadsheet that David provided in week 11 under the Python Lab folder for your station lists. One of the columns in there gives you the most recent year data is available. Note that this will all fall apart if you try to import years of data where there are no data. Okay, so be careful about what year you put in here. And then I've got it subtracting 30 because I want 30 years back into history. I want 2018 and 30 years prior to that. Okay, so this is always going to be 30, but this is what's going to give my numbers. So if I was to execute this, let's take a look at what that creates. So that results in this. Pretty much looks the same as that, except now you can see that it's gone 2018 minus 30 gives you 1988, 1990, 1985, 1990. Okay? So what this first loop is doing, this 4 station list, is it's taking the station number from the first pair, in the year from the first pair, and it's doing everything underneath it just on that station and year. And then once it's completed doing all of this for that station and year, then it moves on to the next pair, and it takes this station number and this year, and it does all of this until it's finished. Once it's finished, it goes on to the next one, and so on and so forth. So this gives us the ability of not having to copy and paste this parameter and get request more than once. We just got it here once, and instead we're just going to give a list of our stations and our years, and it's going to loop through all of it for us. Okay, so that's that first little bit there. We've got our station list all set up. We can see what that looks like. We know we're going to take a loop through it. I'll make sure that this is set to 30 years from 1988, 13 years into the future, 30 years into the future. I'm going to leave it at 2 just for convenience on our subset here. All right, now that would work just fine, but we want to do some processing on our station first, right? So last week we did a couple of things like this. Oops, don't do that. We did a couple of things. Yes, Megan, I could. And you can't see the code because it blocks it off, right, in the panel of the cell. That's fine. I don't need you copying too much of it right now. I'm only doing it in pieces. If you tried to copy this and run it right now, it wouldn't work. So I don't want anybody running any code right now. Once I get to the end and show you the full loop to run, I can. It's too much to post in the chat, but I will be posting the full notebook, so you may just have to wait until tomorrow afternoon when the notebook gets posted. Maybe I'll post it this afternoon. I might post it this afternoon for everybody, okay? But right now, I just need you to try to follow along, and if when you get the notebook, you want to recap on some things, you can pull up the video, okay? Station list equals station ID, most recent year minus 30. Correct, Maddie. That's an excellent way to keep notes. All right, Megan, I'll tell you what then, that's fair. I will post the notebook today, okay? So that'll give you everything we cover today. We'll give it to you in a runnable script, okay? All right. Okay, so back to where I was last week, right? We did this part. We did our data frame creation. So we took in 1 station's worth of data with our GET request, right? Pulled in the files. I wonder if I still have those files. Oh, good, right? So pulled in our files in our folder. You can see this is here when I was writing my script. So the GET request pulled us in for that station that we worked through last week. And then we did our glob for everything in that file with the same station ID. And I did that for file name. And then inside my read CSV, you can see here, this is where I've tackled the parse dates. So I will pause here for anybody who wants to take their concat, which should look identical to this from last week. So nobody should have to feverishly type away. And I think Kimberly said it in the chat a little while ago that she got the parse dates to work and the index. Excellent, well done. This is one of the ways, and there are more, that I got mine to work. So inside our brackets, we've got our file name that's coming in from our glob. and parse dates equals date time. I'm renaming my column for future use. And then inside square brackets, I've got the date time with a slash, / in between it. That is the format from the source CSV file. Okay, so there's one of the things that we discussed earlier today, the parse dates. So now that works, but we want to do that per station, right? We want to do some pre-processing. So I've got this loop here that goes through every station. So if I want to do some grouping or some processing or some loading inside my loop, I might want to add that up. Okay, so that's in fact what I do. So I have taken this data frame creation and I've dropped it right in to my loop. Okay, yeah, I don't know why that's red. Probably because of the spaces. And again, don't worry about kind of pulling this up here yet. I will give you the fully formatted text. Okay, so now I thought, all right, so I'm going to do the same thing we did last week with the data frame, but I'm going to put it up into my loop so that I can do each station at a time, so I don't have to keep copy and pasting. Okay, so we know what the concat does. Wonderful. I wonder if I can make this work because I've already got the files. If I set station ID, I should be able to. So give me a second here because it'd be nice to have some visuals. And oops. No, what's not defined? Oh, really? Didn't I define pandas? Oh, sorry, excuse me. I've got this tab still. Okay, so this still is just where we got last week. Everybody, we worked together, we got here, right? We brought in at least one station. We put in our concat. What I've added here to share with everybody is the parse dates, but there shouldn't be anything new in what I'm showing right here, okay? And then you should have had a table come in like this. I've got a date time, but I still don't have it indexed, and I've got 30 columns or whatever, right? But there it is. So from there, like I said a moment ago about where we want to get to, we want to start now, trimming out our data, okay? So I used these 3 lines of code. Okay, so once I had my data frame, just like you see here and everybody got last week, then I created a new variable. Okay, I called this variable column list. What I did was I took the ones that I thought might be useful. I took date time, right? I renamed it up here so I know it exists. I took the station name because, hey, I want to probably know what the station name is. It's better than using the ID. So I took the station name column. Also in my list, I wanted max temp. At the time, I thought, hey, we're looking at temperature. Maybe I want the max and maybe I want the min. Okay, so I made a list here. All it takes in Python to do a list is square close brackets and separate your items by commas. So now once I had a list of columns, I can now just go df, right? My data frame I created above and the one you see below. And inside square brackets, I can just call column list. Okay. And I decided I'm going to create a new data frame named data_df for that. Okay. And then I thought, this has got, some strange characters in it. It's got the degrees symbol. It's got spaces. It's got, other issues. I don't like that. That's not going to help me in my code. So a nice simple way to rename is if I go data frame df dot columns equals, and then you'll see it's very similar format. It's a list, but instead in this list, instead of it saying station with a capital S, capital N, space in between, I've done all lowercase with an underscore in between. Likewise with maximum and minimum temperature. So now if I run this little bit here, it will now change my data frame to look like that. Which is a little more familiar, right? With data frames we've been working with in the past. We don't have 30 columns, we got all this other stuff where we're looking at temperature, we've got a station, and we've got dates. And you'll notice that this is still in days. Okay, so we've got every single day from 1988 to 1990. Right, because it only took 3 years. Okay. Yours will have more when you do it, but this is a sample set. Okay, Peyton's asking about the NA values equals NAN. You could do, but do we have NA values? Are we bothered about them right now? What's our end goal here? That's a real question, not rhetorical. What's our end goal? What are we working towards here? All these steps, what are we working towards? Min, max of minimum temperatures. Thank you, Maddie. Excellent. Right? So you could put the NAs in there, but maybe we don't need to. Right? We can keep slogging away, and if it becomes a problem, we come back and address it. Right? I got stuck in the part because I couldn't figure out how to type in the degree symbol. Good comment. Right. So how did I do this? Excellent. Thank you, Nigel, for speaking up. Okay. Yeah. How did I type a degree symbol? Okay. I did show this last week, but any ideas? Anybody remember how I may have done that? Get it from Google. Absolutely. You can get it from Google. Or you can use Python, right? If you do dot columns, we have used this lots and the lots. Okay, it gives you a list of columns, and then you can copy and paste out of here into one of your cells. Okay, all right, good question. All right, Julia, I got a lot of stations on the Excel sheet given, don't have a max or min temps for some years or months. For this exercise, no. Dave's going to address it. So, okay. So I'm going to move on and let David continue that conversation. Okay, so here we go. We got a data frame, and we got it looking kind of right. So what are we going to do next? Okay, we're going to get tricky. Okay, this is where the real conceptual stuff is going to start coming in. Okay, so let's break this nice little bit of code apart to figure out what it's doing. All right, so I'm going to create a new data frame. Copy. Okay, I'm going to name this one max df monthly. So we know that our data as we brought it across is daily. Okay, so we've got daily max and daily minimum temperatures in our table. So our end goal is to get the maximum and minimum of the minimum temperature for January and July for all of our years. Okay, so the way that I thought about tackling this was, hey, I think somebody, was it Maddie or Kimberly, somebody said in the chat, gotta set our index. Okay, perfect. So let's do that, right? And I figured, hey, let's not waste lines. I'm just gonna cram it into this line. So all I've done is I've just gone the same as you've done before, data df.set index date time. Okay, that's there, but I've tacked something else onto the end, kind of a 2-in-1 scenario here, right? Instead of having to do another line or another variable. And what I've put on the end is a function called resample. So this is meant to take our data set, specifically time series data sets, and resample them, so group them in such a way that you desire. So you can do it by weeks, different periods of time, quarters. It's really big, widely used in financial data sets because you can break up your yearly data into quarterly data and do maximum minimums averages of a quarter, like first quarter, second quarter, third quarter of a year. You can change that to be a fiscal instead of a calendar quarter. You can do all these other kind of things. For us, we've got daily data that we want to be grouping up to monthly. All right, so what I've done is resample with a capital M, tells it that I want to take my daily data, group it up to just one record per month per year. And then it requires some way to do that. So when you're grouping all those dailies up into a month, which value are you going to take? Do you want to average it? Do you want to take the max? Do you want to take the min? Do you want to take the median? There's a whole bunch of things you can do. You've seen us use some of these before. But right here, we're looking at the max. So I've started with the max here, right? So I want the maximum for the columns in my data frame that I'm resampling by month and setting my index all in one line. So this is a powerful little line we've got going there for our data set. Okay. So let's take a look at that. So if we were to run that and look at it, notice how now our table is January, February, March, April, and it's the last day of the month. We could change that, but it doesn't really matter for us. It's just the index, right? And again, remember what our end goal is. As long as we've got a maximum for the month, we know that this is grouping it by the month of January. So it's just taking the last date of the month and it's done it that way. I think it's quite nice, actually. Anyway, so this means that the maximum max in January was 13.5 and the maximum minimum was 6.5 in January at William Head in 1988. Okay, so we're getting closer, aren't we? But this still just gives us a monthly max for each of the years. So we're not quite there yet because how do we put all of the Januaries together? Okay. So that's what we're going to do here. I've named another data frame. I've called this one month_max. All right. And here I'm going to take my month df monthly. And I'm going to imply the group by function now. Okay, because I'm not resampling on a time series scale anymore. I'm just wanting to group by a particular month. So I want all the months in my data set to be combined into one set of data, one record for all of those like months. And I want the maximum. So that, what I'm trying to get to is the maximum temperature in January for all the years for each of the months. So if I do my group by on that data set, the table you see below here, and I want to group by my indexed month. So this is, a nice little thing why we indexed above, because now, as we've used before, we can use our index and go .month and know that that will group by our Januaries, our Februaries, our March, and et cetera, et cetera. And then we've got our familiar max at the end there. So what does that look like? So looks like we've taken our entire data set that started out as 1096 rows, 1096, something like that. 10,000, 1,000, 1,096 records, and we've boiled that down to 12. So now we have 12 months, 12 records for our given station, and we've got the maximum temperature for January across all years in our data set. And we've managed to do that in 2 lines of code. Not bad, hey? Just took a little bit of thinking about what we had and where we were going. All right. And then what have I done here? Thank you, Kimberly. So what are we doing here? I'm not entirely sure what. Oh, right. So although you see the data table below, it has the station name in it. Your group by doesn't include that column. So this last line here is just to put that column back into this table. All right, Rachel has a question. This is a good point in the code to stop. A little confused about how this is all January. Wouldn't each number be months? It is. So date time 1 is January, date time 2 is February. Right here, we've just got every month. So for all of December, for all of our years, it's the maximum for December. For January, it's all the maximums for January. You're right. These are the 12 records. These are 12 months. Each row is the maximum temperature for every January in our data set. And we started with daily minimum and maximum temperatures. So there's one day in my 3-year data set here, one day, at least one day, where the maximum minimum temperature reached 8 degrees Celsius. We boiled that down from our 1,000 records into 12. Okay, so that gets us our maximum. So what I did was I just repeated the same thing for our minimums. Okay, just like that. I'm not going to go over this. It is the same, except instead of max, it has min. Nothing else changes. And then where do I go from there? What's this doing? Oh, right. Okay, so we just walked all through that, and that gave us the 12 records, right? But those were our maxes. So then we did the same thing. So now we've got 2 data frames, month min and month max, which is great. You know, we could just look at both of them, but because we like to be creative, why can't we just put them together? So if I run this one, I should, if this works, if I've got all my, yeah, okay. So what I've done here is just use our Pandas Concat, right? We've used this before, it's familiar. And although it looks like there's a lot of syntax going on, you can see that the first term is this, which I take the station name and the minimum temperature from my max table, okay, that we created together. And then the second thing I'm concatenating to it is our month min table that I created here and the minimum temperature. So why am I calling minimum temperature and minimum temperature? And I've got 2 columns that are now both minimum temperature. Why? What is that resulting in? What's this table station by month showing us? Not rhetorical. Right. Thank you, Rachel. The first column there that says min temp is the maximum minimum temperature for our data series, and the minimum, the second minimum temperature column is the minimum temperature for our data series for each month. Excellent. Okay. So here we go. That seemed all pretty good. Hey, that got us basically all the way, right? This right here, this row 1, and what month is July? 7. That gives us the 2 data values to complete that data table that David's got in the Lab 5 assignment. Right there, done. But we've talked about all along that, hey, that was a lot of different cells, gonna have to copy and paste. What was the point of creating our big loop above if we're gonna have to do all this copy and pasting and keep track of it, blah, blah, blah. Wouldn't it be nice if we could just all put it together? Well, aren't you lucky? Because I have done just that. So since we were able to leverage our loops here that we worked so hard on at the beginning to set up, we can cram everything in below that. And at the very end, I'm just going to give myself some more space here, try to make it cleaner. At the very end of our loops, what we're going to do is I'm going to use a function called append. And I'm just going to add each of the tables we just worked so hard to create to each other. Just going to tack it onto the end of it. Okay, so let's see what that looks like. I'm going to restart my kernel just to clean things up. I'm going to clear everything. Okay, so net new, haven't run anything. So if I execute my first one here with my libraries, and then I execute this one here, and it's running with my little asterisks. There you go, it's finished running. So somebody tell me what I have just done there with that one executable. What am I expecting when I look at this? We've been through every step of that. What did I just do? Somebody summarize that for me. Probably easier to verbalize it and not type it in the chat. Don't be afraid of missing something, but this is helping your understanding, because that was a whirlwind of code. But conceptually, what is it doing? Speak up, Maddie. Would you get what for all stations? I want to hear what we just ran. Okay.
Would you get a min and max of the minimum temperatures for all stations?
Absolutely. So what has our code done? We set up some stations, and then what did it do?
Oh, for 30 years.
Yeah, in this case, 3 years.
Since
But
it's, yeah, sorry, 3 years for,
Yep.
from the most recent dates.
Yep. And it went out, right? Picked up the station, pulled that down to our computer, in this case, my computer. And then it grouped all the years together. And then it did all the renaming, and then it did our maxes, and then it did our mins, and then it put it all together in all of 2 seconds. A lot of work for something that takes 2 seconds, eh? So our resulting table looks like this. We've got William Head, our station name, our minimum maximum temperatures for each month, 1 through 12. Same with the Malahat station, same with Port Alice, and same with Kitabat. Pretty great, hey? I thought so myself. But wait, it gets better. That's all fair and well, right? But we're in the coding world, so now I have to look through this, and I gotta, open up Excel and create my other table for David and Adam's document and type that in, and then I gotta find a way to copy and paste that out into my notebook, and then blah blah blah. Don't we have something like Python that can do all this for us? Well, you're correct. Let's lean back to our favorite old little friend, Plotly. It gives us some nice little slick outputs. Just like we've used scatter in some of our other labs, there's also one called table. So what I've done here is I've set up a table. I've said, okay, I want a header on my table. I want it to say the station name. I want my January minimums, my July maximums. I've got my degree symbols in there. I set it to a color. I set my font to a color and to a size. I want it aligned center, so I set it up there. And then what data do I want in there under those headers? Okay, well, I want to grab the station name. I want to grab my minimums and my maximums. I'm gonna have to change that. Sorry, this is an older rendition before David told me I had to change it. Let me just do this here. So we're going to add a line to our code here, and I'm going to go, which one goes first? Nope, I don't want that there. And we're gonna have station name, min temp is really our max temp, perfect, min temp, okay, I'm gonna run that again. Okay, so there we go. So I've got the cell values. So in the first column, I've got my station name. In the second column, I've got my January min temp. And how did I select that? I went back to our old friend here, right? We know there's an index. I know that 1 in the index is January, so I just want January, and I just want July for my July columns. So I'm just building a table here. And double check that ran. So what that looks like, if we run that nice little bit of Plotly, bang, look at that. Nice little table. We've got a column, we've got row names, all our temperatures, all laid out from that data table just there. And we coded it all. And just because we're in Plotly, we've got a little download as PNG, so we can just export it, place it into anything we want. Okay, there it is, all done and done. So I will have given you a workbook that from start to finish in 3 cells generates that little data table that David's looking for, well, David and I are looking for the observed values so that you can focus on your models, your PCAKE models. Okay, isn't that nice? And that'll work for any station for any number of years at all. So you can just change your stations. This will run in seconds, just like that. So while I was working on this, I thought that was all nice. But hold on, maybe I could go a step further. Wouldn't it be nice if I could see all of my data? Well, it would be. So what else could we do with our Plotly table since we've so nicely worked with our data and got it into that 1 station data by month? There's other data in that table. Wouldn't it be nice if we could look at that in a different way? Well, this looks a lot more complicated, but it is still just Go table. Okay, I've still got my header and I've still got my cell values. And let me execute this maybe before we go through it. What it creates is a fully laid out table with a column for each of our stations of our max min and our min min, each station laid out as its own column, and for every month. And so this is a data visualization in a Plotly table that you could export and print into something that summarizes all of that data that we downloaded for 30 years, in this case just 3, but for 30 years worth of station data. Boom, one table, all the stations we need, just like that. And all you need to do is change that station number at the top, and you could recreate this in seconds for different stations all across the country. So this got a little bit more complicated, but we were able to do the same thing. You can use HTML, right? So you've seen me use this a little bit in the markup ones that we've got. So BR here does a line break. So that's how I got William Head and then minimum temperature below it. Okay. And then the B either side is to put it into bold. So you see that it's in bold font. That's all that does. I've got STNS with an index value of 0. So what that's doing is I've got all my station names by pulling them out of my table, the station name column, finding all of the unique stations that are in my table. That produces a list of the stations, and then I can call that list by taking the first value, second value, third value, fourth value in the list with a 0 index list. And that gets my headings. Then in the cells, similar process to the one above, except I add this second mask or condition in here, whereby I only want the values in my first column for my first station, in this case, William Head. And that's the same thing it's doing it over here, but I want it for all years. Okay. And then I've got my color, and then I've got alignment I can do as well. I was going to say something else. Oh, and then there's this one other little bit of code that I really quite liked. All this is doing is creating a list of month names. So this has nothing to do with any of our data. This is just creating the names of the months, January, February, March, April, May, all the way through in its own little list. So if I copied that and just ran that, that's all it does. But because I know that my data is sorted in the months 1 through 12, but I want it to actually say January in my table column, I just use this little bit of code to produce a list of January, February, March, so I don't have to write it all out. So this is just a little demonstration here of the things that you can do with the code. They really are quite limitless, but if you start thinking about the concept like we've done today of where we started with a 31 column data frame, or rather CSV, 31 column CSV that we pulled down from the internet with daily temperature data. And within a few lines of code, we've managed to get this output, which was the output we were being asked for. Okay, based off our minimums, it gave us our max, it gave us our min, and it's grouped by month. All right, so that was a lot. I know it was, but I hope that the take-home point here is whenever you're designing code like this, and like the question the lab is asking you, think about where you're trying to get to, right? For every step we've reviewed here, we've been thinking about where we're trying to get to, all right? So it's about learning those tools on how we group, how we parse dates, how we index. We need to know some of those basics. But I haven't really done too much beyond that for the manipulation of the data tables, as long as we kind of were able to navigate that path on when we group by to get to this end goal of a January minimum for all years. Okay. So questions, comments. I would like to spend the rest of class day with people working on this for their stations. So I think what I'll do is I'll post my notebook up to Brightspaces early so everybody can bring it down. But my expectation is that people talk to me and that we review certain things. I want people to understand. I want people to take this opportunity. It's our last class. I want people to take this opportunity to ask me, hey, what if I wanted to go one step further? Or, hey, what else could I do with Plotly? Or what other tables could I create? Or, there's really lots of things that I have kind of summarized in this last bit of code to show you the potential of where we started by pulling in a single CSV to having a full-fledged block of code that goes from a Environment Canada weather data table to a summary data set that can be used to make conclusions from, or draw conclusions from, or run analysis on, or just to present the data. If somebody asked you the question, how would you get there? And this is my interpretation. Okay? All right, so feel free to ask me questions while you're asking questions, while we're talking about it. Let's just have some discussions, etc. I will get this notebook published, but please don't let us just hang out in silence. Deal? No. Awkward silence.
I have a question about, sorry, I'll just close the window. I have a question regarding when you're finding like the last year of data for a certain station. There's a couple different columns. There's like it just says first year and last year in the Excel sheet that David posted. But then there's like hourly last year, daily last year, monthly last year. I'm assuming we're going with monthly last year, maybe?
No, daily, because it downloads daily.
Okay, daily. Okay, thank you.
You're welcome. And that's just something we ran into, right? When we started this, we found the little, get request. Sure, we can take whatever we want. But then we tried and it was just giving us daily. So we just rolled with the punches, right? And hey, so it's daily. We know how to work with that. So that's how we ended up there.
Okay, sweet.
But
thank you.
Yes, you're welcome. Just working on pulling this. Making that one change to my prepared notebook for the cone names. Okay. In the shared notebook that I've created as well, I've put some resources, some web pages for some of the Python code that we're using, namely the Plotly tables, the Pandas Resample, and the Pandas web crest, plus the weather historical station data from Environment Canada and the gridded PKIC websites on there for you as well. So let's post that up in here. Anybody, any other comments? I went through a lot fast. Is everybody just in shell shock, or is everybody like, yeah, no, I get it?
I have one. It's not necessarily regarding the code, but
Mhm.
Is it not problematic that there's only one station on that list from the Northwest Territories?
Oh, that's kind of to David, I guess. He's muted. David, you're muted. Okay, well, he's unmuting.
Problematic?
The shared notebook is up. Go ahead, David, sorry.
Yeah, is it problematic? Is that,
Yeah, that's what I was asking.
how do you mean?
Well, just as far as like getting a good representation of that fairly large area of Canada.
Oh, I see. So
Well, the
one
model
thing,
isn't from the observed weather
Sorry?
station data. The model doesn't come from the station data, does it?
no.
Oh, okay, that makes more sense then.
But one thing about missing data, it doesn't have to have every single day in a 30-year period. I can't imagine there'd be any station on Earth that would have that. So the WMO, World Met Organization, I think I wrote WHO to somebody, WMO, has rules about creating these climatic normals. You can be missing so many days in a month, a month in a year, so many years in a 30-year period, not consecutive, this kind of thing. So yeah, you don't actually need, so if you're trying to find a data set with all, every day represented in January for the 30-year period, you're probably not. I mean, if you did, that's great, but you're probably not. And it's okay to be missing, a couple of Januaries in the 30-year period. So that probably opens out a little bit. Which station has data? Yellowknife?
There's only one. I'm trying to remember what it's called now. 1 second. Switching between screens.
I mean, NT proper doesn't have a whole lot of places. It's got a lot of villages, which don't always have very long records necessarily.
Yeah, it's called Sachs Harbor, Satch's Harbor, something like that.
Sachs Harbor's got a full record?
It starts in 1955.
And Yellowknife, okay, so I think what might be happening is sometimes like we saw with Victoria Airport the other week, it goes from 1953 to 2013, but it doesn't stop in 2013. It just, the station is kind of renamed, probably because it's repositioned, and then it continues, it's ongoing. I bet Yellowknife has more than one record like that. Sachs is actually probably just about the smallest community in Northwest Territories. Adam's smiling because we have, I've been up there a lot actually, and we had a project that involved, I installed equipment on a 110-foot tower. We don't have to climb the tower. You do it when it's laying on the ground, and then they pull the tower up, tip the tower up. But for a couple of reasons, probably one in particular, the project didn't work as hoped, which is hugely disappointing because it's a lot of money. Oh, I see.
Yeah, sorry about that. I just, for some reason, one of them's isolated from the others.
Okay. Well, Sachs did used to have an upper air station, which is why the record would start in 1953. That's when the upper air station was installed. But part of the Canada-US, I mean, in a sense, it's part of, it spills into sovereignty and defense issues. Like that's why we have so many of these stations. It started out in the Cold War, early Cold War period, just post World War II. And that's why if you kind of zoom back, you'll see stations dotted right along in almost like the same latitude. And that's the DEW line, the distant early warning line. And each station used to be a big radar installation. The radar installations are still there, which kind of people don't really realize these days, but they're not, they don't have any human operators anymore. They're they're completely automated facilities. I mean, not quite as many of them because the radars are better, but yeah, no, the radars are still there. Are climate ID and station ID the same?
No.
Definitely not.
To Stormy's question, in that paired list, the station list, you can see on the screen share, if you've still got it up, that I've got a station ID of 129.
Yeah.
And then I've got the year 2018. That's the most recent year of record when I looked up station 2019 in David's table. And then I've gone 30 years back from there. Because I didn't really
Okay.
want to calculate in my head what 30 years ago was, the year rather, 30 years. I just didn't want to do that in my head. So I said, hey, Python, you do it for me. But I wanted it to be the most recent.
Okay, yeah, that sounds great.
Yeah,
Makes
like
sense.
station 65, right? They've got 2020 data in there. So just go 30 years
Yeah.
back from 2020. But it's station
Okay,
ID
perfect.
specific. Yeah.
Yeah, absolutely. Okay, thank you.
You're welcome.
Hey Adam, I just have a question about the like the GET request that we use to get that data
Mhm.
into Python. Like, what else can you use that for? Like, what type of
Ooh.
data does that require?
Anything.
We were using climate data, but I'm just wondering what else you could do with that.
Anything. You can scrape web pages. You could point it towards Twitter and scrape data off Twitter.
Okay.
You can
Interesting.
do anything you want with it. More commonly, as part of our course in the geography department, what I've used it for quite often is off FTP sites. So if there's an FTP site, like we used that before, and they've got daily data or something, and it's broken out, or even in monthly, and it's broken out into lots of different CSV files. I don't want to have to go and click every single one of those. And what if, I want to keep this script for months or years, and I want it to be as most recent as possible. Then I can code it up, and I know that it's going to go out to that FTP site, and it's going to download them, pull them back, and then I can use them. There is actually one step further we can even go, is that in Python, that GET request doesn't need to download data. We could have done this in GET request, pull the CSV data we need, hold it in memory in Python, and then create our data frame. And then we could have just saved our data frame out to a CSV file, which would have taken up no disk space at all and still got us the same output. We didn't go to that extra length in this script because it's not worth it, because you can just go and delete the file tomorrow if you wanted.
Right.
And,
Cool.
and it's not a ton of data. So, yeah.
It seems super useful.
Yeah, there's some really, really crazy stuff you can do. When I first looked at this, I was like, really? You can just go to any website, and if you have the right little link there, you can build your own query and take any information off that page. Yes, you can. Quite literally point Python to a web page and ask Python to bring something back from that web page, any web page. One of the things that I've used, not quite the GET request, well, no, I've used the GET request for it, is for any of you who've used GIS, if you've heard of a REST endpoint. So this is where organizations will publish out GIS layers or maps to a REST endpoint that an API uses to pull the data from. And when I say an API, you think of Google Maps, right? It's a map, but lots of others have it. Like if you look up CRD or Sanage, you pull up their GIS map. It's a map service, right? And it's an API. But the data they're showing is stored at what's called a REST endpoint. And if you know the URL for that REST endpoint, you can point Python to it and pull the data down. So for example, I don't know, you want to create your own DEM from contours. but you don't have them. And you notice that on this CRD web page, they've got contours, but there's nowhere to download the file. You can actually go to the source REST endpoint and create your own little Python loop to pull those contours down to your local computer so that you can create your own DEM.
Sweet. Thanks for going over that. Super interesting.
Yeah, lots of power to it all. You're welcome.
I feel like the stations I chose have massive ranges in their temperatures. I don't know if maybe I did something wrong, but they seem kind of crazy.
Ranges how? Where?
Like, say for like the July max temp, because that's like the maximum minimum temperature, right? But like for one of them, it's like still, I don't know, 21.7 degrees, but then like the minimum in January is like -24. That just seems wild. I don't know if I did something wrong though.
Where's the station?
It's in Terrace. So I mean, I guess, but that still seems crazy.
How long does the data set go back? Like
Oh,
year. What's the year? 1980.
the first year of data is 1953.
So the warmest minimum temperature ever in July was 21 degrees.
Which doesn't make sense because I just looked it up and like I just chose a random, I chose July 2012 and like like July 1st, like the maximum temperature that day even was only like 11 degrees. Don't quite understand.
Sorry, I didn't understand that last bit.
I looked it up in the like historical data just on like the climate weather site and just to take a look at arbitrary July. And I mean, say for example, July 1st, the maximum temperature was like 12 degrees and the minimum was 8 degrees. So I'm kind of perplexed.
And what was the minimum that you had in your output?
Minimum for July was 4.9.
Okay, so that fits.
But then, like, isn't the max temp? I guess I get kind of confused. Like, it's the maximum minimum
Yes,
of the month.
yes.
Hmm.
So if you take all the minimum temperatures, which was the highest?
Well, that still seems like very high. But okay, cool.
I think it's okay. I hope it's okay. But this is great. This is how you validate data sets, right? You have multiple users go through it and find holes in it.
The thing to do there is to find out when that occurred and pull up that January. Look at all the values around it.
That's what I was thinking of doing, but then I wasn't 100% certain how I was going to go about doing that.
Okay, well, let's talk about a couple of ways. How would we go about that?
Wow. I mean, I feel like if I isolated the station and then looked at, like if I then listed the all the maximum minimum temperatures for July of that station, and then could find it somehow that way.
So one drawback to the way that we've done this is that we don't have a lasting data frame of all of our stations' full data. So in mine, after I've run it, I've got no way to look at all of my daily temperatures for William Head. I would have to take out my concat. And so I'd probably do this, take that out and put it in somewhere to do my test. And then make sure I've got the station ID I want in here. You know, what did I say my IDs were? Let's call it 129. Oops, 129. And then run this. So if I ran that, now I've got a full data frame for dailies. And then what do we want to know? Data underscore df dot min temp equals. I think those are probably still numbers we could try. Let's go. I don't know if negatives work. It might do. 8.5. And now that will return you every record in the data set where minimum temperature of 8.5 was. So I would probably use that, and I'd figure out where that was, because you've just run out to the end of the table. You should return one value, but then it will give you your month and year of which it occurred. And like David said, you could then go hunting down to see what it was like around then. So to do that, we could go where df.index.month equals 12. Ampersand data df.index.year equals 1 and 0 in my case. Brackets. Maybe. No. Bracket. Oh, bracket. Oh, does this not have an index in it yet? No. Oops.
Adam, I did do that, and yeah, it actually does make sense. The
Does
numbers
it?
do make sense. Yeah.
Excellent.
July 2009 was just terrifying. Fun
There you
fact.
There you go.
Cool. Okay, thank you.
You're welcome. I want to finish this now. Really? Oh, let's get the right brackets. Really? Doesn't like the ampersand? Oops. Oh, wrong length. Oh. No. Okay, I don't know. I'd have to work with syntax, but you figured the right thing out. Just be able to. Oh, I'm gonna give up on this in a minute.
Can everybody else see the labs that have gone up in Brightspace? I mean, I just want to make sure everyone can see. First part of lab 5. Can you all see that?
Or
Yep.
I can at least.
Okay.
The recording or the
No, the recording on Brightspace. Yeah, because Megan can't see beyond lab 3. So, I mean,
Unless it's titled something different, but I've literally refreshed and looked through everything, and I only.
yeah, no, they're all there under labs. Here.
I don't
There.
see it past lab 3 either in the media gallery.
Yeah, that's where I am.
Well, no, I'm not posting anything to the media gallery anymore. I put all the links there. Remember I sent out that message. Second thing under course content, it's like before week 1, YouTube lecture labs and links, current grades. Because Kaltura keeps being a problem, so we've stopped using Kaltura. So all the links are YouTube's.
Oh, okay, I can see. Yeah, Peyton sent me the YouTube link. I just thought it was on CourseSpace itself. For Adam, for the lab, you said that in the code that you minus 30 years. So then, are we just downloading one set of year data? Or maybe I'm confused. I'm trying to watch the first video now because I didn't know that it was there. So I didn't have like any of the data. And I'm seeing that we have to download like the daily data, but you wanted like 30 years back worth of it, right? So how am I getting that?
So I've posted to Brightspaces under week 11, Python Lab 5. There's my notebook you can pull up.
I have that.
And the stations are the station numbers that you've chosen. And then from that spreadsheet that David posted with all the stations that have at least 30 years worth of data, you can find the most recent daily data year, which is what I've done here for, say, station 129. And then we want, for our questions, so for the lab 5 questions, we want a 30-year chunk of data. So I've taken the most recent year and put 30 in here. So for changes to mine, you're gonna wanna change your station number and the year. Don't change the minus 30, you don't have to do that at all because you want that to stay the same. And then you just wanna double check that the number of years here in your loop is 30, but I'm fairly sure I changed that to 30 when I posted it. So years,
Yeah, but where am I, so like as I'm downloading the original data, am I just downloading like this year's data? It's supposed to know to take 30 years off, or like what am I, where am I pulling this data from? Because I have to do a set of data, right? Like in the lab one, you said, or it has daily data reports that we're supposed to download.
Daily data reports we're supposed to download.
Megan, I think
No.
you're confused. The code downloads the data for you. So you just run the code and then it downloads it into your computer for you.
And you just switch the code numbers?
Yeah, you just put your station number in and then it puts it into, you just have to make sure that you have that folder in like on your computer that's titled the same as the code. And then the code will actually go to the website and download it all for you.
Oh, okay. Wow, it's such a smart code. Okay, thank you, Rachel.
Yes, thank you,
no
Rachel.
problem.
Yes, no, I tried to get the code to do the heavy lifting for you, Megan. Just like Rachel said, though, do be careful that the directories line up, right? We spent a lot of time on that last week, ensuring that you've got a folder that this maps to correctly, meaning that in my example here, I have my home folder. In this folder is where my notebook is, right there. In this same folder directory, I've got a folder named Lab 5 Data Files. It must look like this for this code to work. So you must have this Lab 5 shared notebook in the same directory folder as you have created a Lab 5 data files. Otherwise, it will not run.
Hey, Adam, can I ask a quick question?
Yep.
So down below where we're producing the figure,
Yeah. Which one?
the first one. So I'm just changing the months and then I know where to change them, but I'm just wondering, yeah, so right there where it says the like station underscore data by month index, what does that one there represent? Is that January as well?
Mm-hmm. That's why it's named January. So remember, what does this table look like at this point, right? So if you're ever, wondering, well, I'm not just gonna put in random things. Oops, don't do that. Take a look, right?
I see.
Right?
It's just
Well, what is that table, right? Well, here it is. How do we get to that table? Okay, well, date time 1 is January through 12. So that line that you've got here, right? This is just one of our standard mask. So we want the station name where the station data by month equals 1. We just don't need to put dot month because it's no longer date time. It's just an index. There's another way we could do this, but I chose to go with this dot index method because it's a little more familiar because we've used it to go dot month, dot year, but you can just go dot index if you know the index value. But really it's just calling every one where it says 1 and 1, but we know it says 1 because of the process we used that put this into from a date time index into a month group.
Okay, so we're leaving the station number then, or we leave that as 1, and then the 4 below we're changing to be winter and summer.
No, you can run this as is. This doesn't need to change at all.
Oh, sorry, but like if we just want to change our months.
But you don't.
What? It says to choose a winter month and a summer month. And I just thought of switching it up.
Sorry, did I read that wrong? I thought it was just January and July. David, that's probably my fault.
Oh, yeah, I think you can just choose in the lab. It just says choose a summer and winter.
Yeah, a summer and winter month.
That's my fault, Stormy. That's my fault.
No, it's okay. I just thought I wouldn't copy exactly your code.
But you could.
Yeah, okay. Thanks.
You're welcome. Just for any of you who did pull that Lab 5 questions document before today, just go back and double check and download it again, because there was an earlier version up there. So be sure that you've got the most current version, please. And maybe that's where my confusion is coming from. Okay, thank you.
Search up a location. What do you mean? Like to type in Vancouver and the map goes to Vancouver? I don't know. I doubt it. But if there is, I don't know offhand. I just scroll around and then draw my little box.
Can I just double check one thing with the years that we're supposed to be looking at? So in our code, we're using the most recent 30 years, but then, for like the climate models, you use, certain specific years, like say 1971 to 2000. Are we supposed to try and match the observational data to the specific time frame we're using from the models, or does that make sense?
Oh, it makes sense. Yeah. Sure.
Yeah. Okay.
Depends on how closely it fits, right? Is there a time period that does work for you or not, right? I mean, they look what averaging period 1971 to 2000, 1981 2010, 2040 to 2069, 1961 to 1990. So yeah, each one will have it slightly differently. I mean, this is more of an exercise of just comparisons, right? We're not looking for detailed data results. So if your 30-year period is close, I would say, well, not too bad. But if you wanted to make it exact, you have the tools to do that too.
Okay, I just wasn't sure if so if I was using, a model that had 71 to 2000, whether or not it would be then incorrect to just leave the observational data as like the last 30 years.
Well, probably, because you would have you'd have no overlap.
Yeah, okay, cool. I just wanted to double check.
So excellent point. But you have the tools, you know how to do that, right?
Yeah.
Just change the year. Go 30 years back from that.
Cool. Thank you.
Or if you just didn't like the negative, how would you change that? Right? I could instead go 1988 plus 30 years.
True, true.
That's some flexibility.
Lovely.
What do you mean by box?
You want to try to select one grid cell.
Oh.
And so try to keep the box. It just happens to, instead of be a point select, it's like a little drag box select. So just try to make sure that you only select one grid cell.
I guess it must be doing the whole country on these plots before you isolate a particular little zone. Because it
Yeah, I
makes
guess
plots
so.
before you do anything, so it must be the whole country.
Yeah, I assume so.
Oh yeah, no, it's taken, yeah. It's a good middle of the road data set. Oh, it's PKIC 12. I think PKIC 12 is an average of the 12 models that they like the best. Because PKIC 12, the model context plot, drops it right in the middle of the crowd.
Ah, I got it. I think it was Kimberly. I finally got it.
Yay.
Using something called .loc. Handy little thing. This will just give you the year and month.
Neat. Well done.
Can I share for 2 seconds?
Yeah, of course. I got nothing.
This is where all the posts are for the labs and the lectures. If anyone's still not sure, they're here. This is under content. So there's week 1, readings, week 2, all that kind of thing. So it's the second one. You just go to there. There are the grades as well, but all of the YouTubes are here. Yeah. Yeah, we keep getting messages that Kaltura is having intermittent trouble. This continues to happen. And I pushed help desk about it. They said Kaltura tells us that they're upgrading their servers or adding more servers or I don't know what, but yeah.
Hey, David, just wondering, Johan's lecture and then the lecture, I guess it was yesterday, will those be posted in the next few days and be on the final?
Oh, yes.
Okay, perfect.
I think the, oh no, maybe it's not.
The last one that's on there is the 31st, I believe.
Right, so
But I
last
mean-
week's. Okay, yeah,
Yeah.
no, and I've been on Zoom all day yesterday and today, so.
No worries, yeah.
One of them's finished. But yes, yeah, no, I'll put them up here as soon as we're done. Actually, I have another Zoom right after this. So
Awesome, thank you.
yeah, with my bandwidth, I can't upload and Zoom at the same time. I tried that once. It wasn't pretty.
All right, everyone. Well, that's pretty much a wrap. I mean, thank you all. And we had to